So I got a backstory. And the backstory is this. You are currently in a dual credit class. You know this because you registered for it last week. Okay? I don't know, maybe last week before. I don't remember when it was. But anywho, one of the caveats of teaching a dual credit class through the tech is that we are required to give the NTC final to you. Okay, so the final that they give at the tech for trigonometry with apps is the final that you will take here in this class. Okay? That's one of the requirements, has been the entire time. Okay? Over the past few years, the main complaint from you or from your predecessors in this class has been that NTC questions have a different wordage, have a different vernacular, have different ways of saying the exact same thing. Okay? So now that we are in trig, and we, like, up to this point in time, we've all been doing your algebra reviews and conic sections and all that stuff. Well, we're going to use that, but that's not technically part of trig. Okay? Now that we're in trig, now I have an entire cache of questions that I can use from the tech. Okay? So we're going to start mixing those in. On the goldenrod sheet that you got yesterday, the whole back side is all NTC questions in their vernacular. Okay? Okay? The three examples that we're going to do today are all NTC type questions in their wordage. Okay? All right? What? V-E-N-A-C-U-L-A-R.
There's an R in there. It's V-E-R.
V-E-R? Vernacular?
Yes.
It's V-E-R apparently. Never was a good speller.
Binocular?
Greatest invention ever? Spell check.
Yes.
Okay? So, here we
Go.
go! That's not the one.
We did that yesterday.
There we go. Okay? So, we'll warm up with this one. Through how many radians will the hour hand on a clock rotate in 48 hours? Okay? This is a question stolen from an old final. Side note, I'll present the question, and then I will give you time to work, and because the struggle bus has a bus stop right outside the door, so we're all getting on and off the struggle bus today, right? Just like yesterday. I would on this one. I would too. Okay. So in 48 hours. How many revolutions does the hour hand make on an analog clock? How many revolutions? 4 revolutions, right? Right? Hour hand on a clock goes 1 full revolution every 12 hours, correct?
Yes.
Okay? So that means in 48 hours we've made 4 revolutions. Right? Each revolution is how many radians? 2 pi. So this would be 4 revolutions times 2 pi radians per revolution is going to give me 8 pi radians. I will tell you that if you have the ability to cut through the words to get to the math, this will be much easier has an area of 108 square inches. The radius of the circle is 6 inches. What is the arc length of the sector? What's a circular sector?
Section of circle.
So what is that? What's it look like?
Pie.
Piece of pizza. Slice of pie? Slice of pizza?
Yeah.
Okay. Alright. Good. What am I looking for in this problem? I'm looking for an arc length. What's the only formula that I have for arc length?
S equals R theta. So you do that, brother, Mr. Rowe.
Do I have theta?
Nope. No.
Do I have r?
No.
Yes. So I've got r, need theta. Okay? How can I get theta out of the information that I have?
Divide by 6.
Divide what by 6?
108.
Okay, what did you get when you divided by
I don't.
6?
This is kind of a guess. I don't think it's right.
18?
18.
So theta is 18.
Yeah. It might
Theta
be.
has to be less than 6.28.
All right. Never mind.
Just so you know. Why does theta have to be less than 6.28?
That's 2 pi.
That's 2 pi. Otherwise, we'd have more than one circle. Right? Okay? So 18 is not going to work. Okay? Anybody else? Okay. Why would I square it? No.
That I would do is just use the radius to find out what the area of the whole circle would be.
Okay.
And then set up a fraction.
Set up a fraction. So what fraction would you set up? Or actually it'd be a proportion, not a fraction. Right?
Yeah.
Okay.
I would do 108 over 113.1 or 36 pi.
Because you did pi r squared there?
Yes.
Okay. So you did the part of the circle that we have divided by the whole thing.
Yeah.
Right? Okay. And then what's your other side going to be?
I don't know.
Why over 2 pi and not over 360?
Because we needed it radians.
Because in order to use it in S equals theta r, we need it in radians. Yep. We'd have to convert it back then. Yep. Okay. So let's go over 2 pi there. Okay. What am I going to solve for in that one? Theta, because it's the only variable that I have, right? How am I going to solve for theta in that one?
Cross multiply.
Cross multiply. Okay. So 2 pi times 108 gets me 216 pi. 6 squared times pi times theta gets me 36 pi theta. Divide by 36 and divide by pi at the same time. Okay. So what do I get when I divide 216 pi by 36 pi? I get 6. So 6 is my theta. So it's almost the whole thing. Because what did you find before, that the whole circle was 113 square inches or something like that?
Yeah.
So it's almost the whole circle. Okay? So now I can go over here to S equals theta times R, and I can say, well, my theta is 6. My radius is 6. So my arc length, S, is 36 inches. Okay? Ready, Med? You know what's coming. You knew it was coming.
No.
Okay, you do this. I'll wait. I'll sit here and I'll look pretty.
Talk about me.
No, I said I would look pretty. So I did
I know.
this.
And you said she's not even looking.
Yeah, because you missed the whole pose. Now the moment's gone.
Come on.
I don't have anything. Yeah, but then what do we?
Just so we're all aware, the wheel, the tire, if you will, is right there. Right? Okay.
No.
I don't have a clue. Oh, we have these inches done. Yeah. So it's the tire was and
Okay.
4 pi.
So the question is, where do we start?
2 full rotations.
2 full rotations, right? Or 2 revolutions, right? Okay. All right. So, but that's it. That's all we can say, right? Is 2 revolutions. What rotated twice?
The pedal.
The pedal rotated twice. So right now, you're sitting as if this were a dot on the pedal that rotated around twice. Okay? We need to get to the linear distance that the bike moved. Where is that?
On the 13.2 radius.
Outside of the wheel, right? So right now I'm on the pedal. I need to get to the wheel. All I've got is revolutions. What can I do? I can go from revolutions to radians. How can I go from revolutions to radians? 1 revolution is 2 pi radians. Now I'm in radians of what? It's important to know where we are. We're still in the radians that the pedal went around, right? So that's how much, the angle that that dot went through. Okay? What about 4.85 inches now? Okay? So you want to go here next? You want to go there? Is that what you're saying? Okay. Because I'm still on the pedal. So now, what have we found? Right now, as we sit, what do we have? Inches of what?
Chain moving.
The chain moving, because we're at the dot. We're at that purple dot yet, right? So that purple dot has moved that many inches, which means the chain has moved that many inches, right? So now I'm on the chain. The chain will allow me to come over here, and if I put an X on that one, how far has that X moved? How far has that X moved?
Same distance.
Same distance, because they're connected by the chain. Okay? One part of the chain is not going to move at a different distance than the other part of the chain, because it's one chain. So that X has moved that exact same distance. Okay? So now I'm on the little sprocket. Right? Okay? So what can I do with that to get to the wheel? Okay? So now I'm in radians that the little sprocket spun. Right? Okay? Why 13.2 inches over 1 radian again?
Because you're gonna go from, because that what you just got is the same angular speed as the 13.2.
As the wheel, yep.
And then you multiply it to go up to rotational. And then to get it into feet, you have to put it into feet.
So now I'm in how many inches that the wheel went around, right? Linear distance that if I was a point on the wheel, how many inches I went around. But I wanted my answer in feet. So that's 2 times 2 pi times 4.85 times 13.2 all divided by 1.54 times 12. That's going to be, if I do all that multiplication, that's going to be 256.08 pi divided by 18.48, which is going to give me approximately that bike moved 43.534 feet.
How many decimals do you want to go through?
3. Okay. Again, I remind you that there is an electronic textbook has been posted on It's Learning. Selected problems have been posted out of there too, so that you can be ready to go for Tuesday. Your test is on Tuesday. It is 3 sides of a piece of paper. Okay? It is 10 questions. Each question is subdivided into particular parts. So sometimes it's 3 parts, sometimes it's 2 parts, sometimes it's 1 part. Okay? So that's the plan for Tuesday. What was that? It's going to be like everything and anything that you've seen this chapter, or this section, I should say. For those that are wanting, we are collecting the gold sheet 85%er. Okay, so below an 85%, we're collecting it for sure. Above an 85%, it is optional. Okay. It is not extra credit.
Just the gold.
Just the gold.
We don't get any points to determine it.
What do you mean?
Or above 85%, we don't get any.
No, I'll grade it like we grade it like normal.
Okay.
Yep. So it would help if you have 100% on your homework, on your formative already. Then it's not going to help you because it goes. We go by percentages. But if it's not 100%,